Okay, this is lecture 18 for incident response technology. So we finished the Splunk introduction in last class. So this class, I will introduce a case study. Well, this case looks realistic, but it's still artificially created by a book author. When you do this, you need to download this case study Splunk file, which is a zip file, and import it into your own Splunk. Oh, by the way, I have released the homework 3. So it is due next Sunday night. So you have 10 days, maybe, well, it's a little bit more than 10 days to finish this homework. So homework 3 is about Splunk. I give you a Splunk file. You download and import into your own. Let me explain it a little bit. This homework 3. So basically, you need to download this zip file. This zip file contains 2 logs. These 2 logs are created by the Apache web server. So in my research group, we have set up a web server on Linux. So by default, this Apache web server program, it will have 2 logs. You basically import it into your own Splunk, then answer these 4 questions. One thing I want to emphasize is that first, you need to give answer based on using of Splunk, because these logs, they are basically simple text file. So you can use some other software or just using some text searching to find answer by yourself, but that's not purpose. So even you can give the answer, but you didn't show that you use Splunk to get the answer, then that will not count. It happened before. Secondly, this one you need to give direct text answer to ask questions, because some question ask you how many events in this specific time period. You need to answer that, well, in this time period, there are like 4,000 events or 3,000 events. Then you can show a screenshot to show where you get this number. It happened in the previous submission, like in the midterm or in the homework 1 or 2. Some students, they simply provide a screenshot as an answer, but they don't show, they don't explicitly answer that, well, for the web server, there are like 41 web server. He just showed the screenshot. So that's not enough. So you need to, if the question asks you to give a specific answer, then you need to answer it with text. Then you give the screenshot to show where you get this answer. So screenshot image is required by many questions, but itself does not count as answer. So just to make sure that you understand that. I think this is understandable. Like, for example, if you're in the future, if you work, then your boss asks you, like how many people have connected to our e-commerce website in the last 1 hour, then you give to your boss. Here, this is a screenshot. Clearly, that's not good enough. You need to give the direct answer. Then, of course, if you write a report, you need to give where you get these answers. So you cannot ask your boss to dig in the answer in a very complex screenshot or data file by themselves. Okay, so this is homework 3. And well, a student just asked a question like where to find networking conference. So for security conference, you can basically Google search networking conference statistics. Then this UCSB, this faculty provide networking conference statistics. It lists the majority networking conference. There are so many of them, so it's if you want to judge which conference is good, you can roughly using the acceptance ratio, percentage of paper accepted as the judgment. The lower the number probably means the better. Of course, this is not absolute metric, but it's a very, very important metric to show whether the conference is good or not, because if a conference acceptance ratio is less than 20%, then usually it's a good conference, very good conference in computer science. If a conference acceptance ratio is 50%, then that means 2 papers submitted, 1 will get accepted. So this is a networking conference, and if you want to find security conference, this one, Professor Guofei Gu from Texas A&M, he provided a nice list of security conference. So these top 4, they are the big 4 security conference. So all the 4, they are very good conference. Then the other security conference, they are listed here. Okay, just to help you find, remember in computer science, conference publication is important, especially in this very good conference. Their publication will count probably more than some journal papers.
Excuse me, Doctor. Can you go back to that website, please?
Oh, well, you simply do Google search networking conference statistics, and this one from Texas A&M, Guofei Gu, it showed the computer security conference ranking and statistics.
Thank you, sir.
And this one from UCSB, it showed the general networking conference statistics. If you don't find their URL, just Google search this one, and you can find them.
I appreciate it.
Yeah, no problem. Why this does not minimize? Well, for online students, they will not see this Zoom bar, but for the student in the classroom, we can see the Zoom bar. It doesn't minimize. Anyway, we can live with this. Okay, so this is a case study. This case study is actually coming from this reference book. As I mentioned in the first class, this is a very good book. It gives you technical details of all the related knowledge in doing networking forensics. So I like this book because it gives you all the detail you can follow. And chapter 8 of this book introduced Splunk and introduced a case study. Chapter 8 is case study, so they give this event log data file. Okay, so of course you need to first run Splunk. And import that file. So I will add data, upload. This is zip file. Give it a name, so it's like a project name. I will just use these ones. So you can see that it limit to host this one. Otherwise, if you check, well, yeah, I haven't checked this, but because I think I have imported 2 data sets. There should be a place where I can see what data set I have imported. But for the newer version, I need to find out where I can check the data set. So anyway, because in the search box, it is limited to this host, to this project name. So we don't need to worry about the previous imported data set will mess up our analysis here. So this one showed all the events in this data set. And this data set has 7,000 events. You can see the source. Source mainly means how many files is in that zip file. If you only upload one zip file, then the source will basically show all the files under the zip file. So this zip file contains 4 files. Firewall workstation, this is Windows workstation log. This is authentication log by a Linux server. This is license. Well, this is not a data log. It's licensed basically because we got the data set from the book. This license.txt just to tell you that this data is copyright belong to that book. So it's not really an event, but since we imported as a whole, so it will be treated as one log. Okay, so what this data set represents? It is artificially created, but very realistic scenario of an attack. So this case scenario is this. It emulates a small business network. The small business is called a dry cleaner company. The cleaners company's network consists of this internal network. So this is a subset. Of course, in this emulated system, all the subnet, they are all private IP address. In real world, any network subnet should not be private subnet, like UCF allocated 2/16 subnet. So those are global IP address. But here, this is emulation, so it just use private subnet. DMZ is a demilitarized zone. I will explain what does DMZ mean. DMZ usually means that when you set up network, you build a firewall between your network and internet. Then after the firewall, you will put your web server in a separate subnet. So usually DMZ is a zone where you host your web server because your web server needs to be visited by all the internet users. So you need to protect it. So you put it behind your firewall. However, because web server can be public access by anyone, and it is very vulnerable to attack. So most attackers, they will first attack your web server. So web server is very easy to be compromised. So in that case, you won't make your internal network, your internal computers to be separate from your web server's subnet. That's why in many companies, they have this DMZ zone, which usually hosts the web server and some other server that you allow public access. Then your internal network will be in another subnet. So these be separate to subnet, and you can protect your internal network better. And the outside internet in this emulation, it assumes that any IP address coming from this subnet is outside internet. So basically, all the outside connection, we assume their IP address belonging to this subnet. And here lists the important system in the company. it's harder to understand what does the company structure. So I draw this picture. So this is from the book, but I draw this picture by myself. So this is a typical setup for a small business. You use a gateway or firewall. So usually you put a firewall device between the internet service provider and your company. In your home, in everyone's home, your Wi-Fi router will behave like this firewall, because actually in home Wi-Fi router, it provides some limited function of firewall function. So you can configure your Wi-Fi router to do some, to achieve some functions that usually can be done by firewall. So this is a firewall, and the firewall has two internal connections. One connection is connection to all the internal computers as one subnet. Another connection is the connection to the DMZ zone. In this simple setup, the DMZ zone has one web server. So this is a web server's name. It's a Unix server. This is the web server's IP address. Here is internal subnet, and there are 3 Windows machines. So these 3 are Windows computer, and these 2 are internal servers. And it's so because this firewall has 2 internal connections, so the firewall actually has 3 IP addresses. One IP address is IP address, is global IP address. Just like your home Wi-Fi router, your home Wi-Fi router will have 2 IP addresses. One is the global IP address assigned to your Wi-Fi, to your home by your internet service provider. Another IP address is a private IP address within your internal local area network. For this, because it has 2 internal interfaces, so it has 2 internal IP addresses. This is this one, and this is this one. So remember, they are in 2 different subnets. This is in 10.30.30/24 subnet. This subnet is 192.168.30/24 subnet. So this is network setup, and the data log is basically the firewall log and the web server log, and also these 3 workstations log. Because the Windows computer, it also has a log file to log all the users login and users running command, those kind of things. So the log file contains, this log data contains 3 logs. One is the firewall log, which is that this firewall. And the workstation log from the 3 Windows workstation. This auth.log is Linux server. Basically, this is the web server's authentication log file. A web server could have many different log files, but for simplicity here, we only deal with this authentication log file. And the scenario is that the cleaning company IT staff noticed a sudden burst of failed login attempt to this web server. This Bamboo is a web server. So they begin to investigate. So if you are IT security staff, you will notice that your company's computer is constantly under attack. There could be a flooding of denial of service attack, a flooding of this failed login attack, and also maybe flooding of scanning traffic, like suddenly from one IP address, they send thousands of TCP SYN packet to all your internal IP address to different port number. So that's quite normal because on the internet, there are so many young kids, they are trying all kinds of attacking software. So that's quite normal. But for some kind of this attack, you still need to investigate. Like this one, if you have failed login attempt, that means someone is trying, for example, password guessing attack to your system. So they want to investigate. And remember, we have this 3 log file. This is Windows, this is firewall, and this is a web server log. And remember, this is web server. So if we want to check login attempts, the web server authentication log will keep all these failed or accepted login information. So I have showed this. Remember, there are 4 sources because we have 4, actually 3 logs of license.txt is also treated as a log. So it is treated as one event. So we want to check the failed login attempt. You can search, for example, failed password or failure because the log, the authentication log have that login information. Let me show. If we just check, just click this source, so we only check this source file, and you can directly see that this authentication log clearly has some burst of traffic here. This is a normal day, but this is clearly a lot of information here. So if I double click to show this one day, you can see that there are a lot of things happen. Maybe, well, I still use it all the time. And you can see this. This is web server's authentication log. It shows session open, session close. So that is authentication log. And here is some the user login and run some command. And if you go down and go down, here is authentication failure. So log name is the user, is it R host, means the remote host IP address, and user equal to Bob means the user tried to log in with the Bob account, but login is a failure. Here is a failed password for Bob from this IP address. It's using SSH2. So basically, attacker tried to log in to your web server by using an SSH connection. Try the Bob account, but password failed. So the slides show you can search for failure, but you can either search this authentication failure, or you can search this the failed password. This is accepted password. This is failed password. So this is accepted password means the Bob account has logged in successfully because password is accepted. So if you check, if we search for failure, just like the screenshot showed, then it showed these events. So this failure seems to could be normal because it's not a burst. But here is clearly something happened because it's a burst of failed login attempt. 10 events in 1 minute, 10 events in another minute, 9 events in the third minute. So it's very regular. Every minute you have 10 or 11 or 9 failed login attempt. Usually humans do not do those kind of failed login attempt. You may log in twice or 3 times if you do not remember the password. But clearly this is a program generate a password to try to log in. So that's why it's interval is very regular. And here we can see this Bamboo server is authentication failure. Login name is Bob. Authentication failure. Login name is user is Bob. So here is authentication failure. Authentication failure. These events. So let me show the screenshot. If we check for the failure, we can see that there's remote IP address attempt to log in to SSH servers. for this amount of time. And if we use zoom out, just a click, because every minute we have 9 or 10 or 11 events, we can see that about 70 failed login attempts happened within 7 minutes. We have showed this screenshot, right? These are the big burst of failed login attempts. And we want to know, first we want to know what username has the attacker tried. Luckily, this Splunk have extracted user here, this user field. If you click this user field, you can see that this attack have tried 2 user account, root account and a Bob account. So we know that attacker have tried password guessing for both accounts. Then, of course, next question would be whether the attacker has been successful to find the password or not. So that's the most important question.
Excuse me, sir. Can you hear me, sir?
Wait, let me. Yes?
Yes. When you click user just now, is that
please wait. Let me check why my video is coming from computer, not from this outside speaker display. Okay, can you speak?
Hi, yes. Now, when you click the user just now, the statistics that are shown, are they for the entire data set or are they related only to the filter?
Well, here is this filter, right? So
Yeah.
it's related to this single data source, this authenticate.log, because this is that web server's log. But I think if we remove this source, the result should be the same. Let me show. Yeah, it's 77. So there are 4 events of this log that contain this keyword failure in the other 2 logs. So in the Linux web server, it contains 73 events that contain this keyword failure.
Okay, thank you.
Yeah, no problem. So we know attacker have tried to recheck the failure, but let me see. Failure, authentication failure, PAM, 2 more authentication failure. Let me see. Let me see failures. Okay, so here is another log that contains this keyword failures, but it's also about this authentication failure. But it's this PAM, 2 more authentication failure. But I think if I type this keyword, it only showed 1 authentication failure. It doesn't show this PAM, 2 more authentication failure. So I think it's slightly different from my slides, because in previous version of the Splunk, the keyword is treated as, even if just a partial of a long word, that event will also show up. So this authentication failure will show up. This 2 more authentication failures will also show up. But it seems in this current version of Splunk, when you type in a keyword, the keyword need to be a whole word. Because when I check this failure keyword, this time 2 more authentication failures, this event does not show up. Because if I check this, it only shows the authentication failure. It doesn't show that the time 2 more authentication failures. Let me see if I can use question mark. No, asterisk.
Professor,
Yes.
if you type failure and then put a star attached to the end, it finds it.
Yeah. Let me. No. Oh. I need Oh, okay. Thank you. So in the older version, if you search failure, it will search for any word that contains these characters. But right now, it search for the whole word. So if I add this star, so it will be either failure or these failures. Yeah. Thank you. So there are some difference between the older version and the newer version. It's case sensitive. Yes, I think it's a case sensitive, but all here they are small case. Anyway, we know that these are failed login attempts, and we know the attacker's IP is this one. We also know that there are 2 users' account has been attacked. So we can check, for example, for the first root account to check what is this. So we can just use failure, then user equal to root. If we just check 1 minute, you can see it's very regular. It's one event in every 9 seconds or 8 seconds, and these are all from the same attacker, and the user is root. So this is a strong indicator that the attacker used a brute force password guessing attacking tools. It's a program to generate this password. What account were targeted? And I have shown that these 2 accounts has been targeted, Root and Bob. And then the next, probably more important question is that whether the attack was successful or not. So we know that there are failed password. So if we remove this failure, just check the user root, you can see authentication failure, root authentication failure. Well, it doesn't show that, but let me check password. So here is the failed password for root, failed password for root. Here, this root is not extracted. So you can see this in this checking, this extracted field, there is no user account. So the root, this part was not extracted by the current Splunk. But we can see that all failed password, and there is no accepted password. So I should use all the time. And well, these 2 are the passwords. These 2 are from different log file. This is that Windows workstation log file. So you can see here it has accepted password, accepted failed password. So, but from here we can see that actually Bob account has been compromised successfully by attacker, because here we have accepted password. Of course, maybe Bob actually logged into this service exactly at that time, but we can see that it's coming from the same IP address of the attacker's IP address. So clearly, this belong to the. Remember, these log are ordered in the reverse time order. So after many failed password logging attempts by the attacker's IP, in the end, the last two is accepted password for Bob from this attacker's IP. So we know that the Bob account has been accepted. If we search for password and root, we can see that all the account here, they are failed password. There are no accepted password for root. So that means root account has not been compromised because there is no accepted password for root that log. But for Bob, we know that attacker has been successful. Bob password was correct with compromised at this time. Well, another thing I want to emphasize that the event here, this time is actual raw data in the event in the log. This time is Splunk interpreted time, so they might be different. Sometimes Splunk interpreted time is very weird. I still don't know exactly what's the reason, but one reason is because of the time zone. If you are in a different time zone than the collected data, then your interpret time may be different. Because remember, all the system log, they not only have the time, but also have the time zone information. Like this -600, so this means this is -6 standard time. So that represents time zone. So if your computer time zone is different from this time zone, then interpret time will be different from the time recorded in the event log. So that one I understand. But one thing I don't understand is that sometimes this interpret time is very different. Like this is 2011 April 26th, but interpret time is 2012 August 9th. I'm not sure why it get that. Let me see what's the current for this one. Yeah, it's 2011 April 4, but the interpret time is 2012 August 9. So and here is 7 o'clock, so that is understandable 9 o'clock because maybe because of time zone difference. But the date is interpreted wrong. And it seems it's hard for me to find out how I can correct the date to make it match with the raw data. And I don't know why Splunk interprets the date very different from the raw data. Any student in the Zoom session, does anyone of you understand this? Because some students, they are actually working in IT department. They know Splunk better than me. And
we would have to check to see if that's like a UTC time being used or something, if we need to cast it. I could do a check for you.
Okay, thank you. Because I tried to find it by myself, but I couldn't find the answer. You can see this is a raw. This is a raw data, 2011 April 26th. This is interpreted time by Splunk, and Splunk interpreted time is 2012. And it seems I don't have a way to modify its interpreted time by using mouse operation. The only one way to modify this time interpretation is doing some command line configuration of the Splunk. But anyway, that's one thing that I'm not fully understand. Another thing is that if you want to list the search result in the normal time order, because we're doing forensic analysis, then you can add this pipeline reverse in the search phrase. For example, Bob reverse. So this command, and you can see this explanation of this command, reverse order of the result. So if we do this, well, the first two, they are this Windows log, because I didn't specify doing search on the web server log. So it showed that there are 3 events from Windows log. Okay, so this is a failed password, and their second page, and failed password and accepted password. So attacker have logged in successfully, basically find the password at this raw data time. So this is a time where the attacker has found the password. So then we are interested when attacker has found the password, what happened next? Because once he finds password, he must do something, right? And we want to find what does the attacker do, because this authentication log will also show the logged in user's command. So any user logged in, whenever they run a command, it will also record it. So if we want to do that, we can use this. Remember, this is this attacker logged in. We can click this time, then we can click this assistant time. Then we narrow down this search to like after this time or before this time. So this is remember. Right now I'm using all the time, so it show all. So if I'm only interested in log after this time, so I can click this after this time, and here it only show the accept password Bob. So let's just show all these all the event after this time period. So I'm only interested in this authentication log. After this time period, there are a lot of data log in the firewall. I'm not interested. So I will just click this source. So you can see that it just finished this source. Then after that time is a failed password Bob, accepted password. And we see this SSHD session open for the user Bob. So so it means that this receive disconnect from this attacker machine. Why attacker immediately disconnect? This disconnect actually is coming from the first. Remember, there are 2 accepted passwords. The first accepted password is by this password guessing attack software. Attacking software, they will try login. If it log in, it will immediately log out. Then it will inform attacker that it has found password. Then the second time login is actually from the user. So this disconnect is because of that password guessing software. It disconnect session closed. Then the second time the attacker logged in manually. So you can see that these accepted password is happened at 4:07 and 4:08 it disconnect because of the software. Then 9:04:33. Basically, after about 20 seconds, the attacker logged in again. After 20 seconds, so that's the attacker manually logged in, accepted, opened, and then here is the user is the root. We don't care because this may be this is a normal user login. No, user login. Remember, this is home is Bob, so this is still belong to the Bob. Bob run this command sudo command. Sudo command will treat it as the user root. So here the user is Bob. Once it logged in, then it run the sudo command. The command is using this VI. VI is a Linux text editor. It's by default, every Linux computer has this text editor. It tries to edit this authenticate.log file. So that means attacker try to first change the log file, try to erase this previous log. But Splunk can do this data collection automatically in the real time. So even attacker logged in and delete the log file, its trace is still collected by the Splunk. Then the attacker tries to run this cpdump command. Remember, cpdump is like Wireshark. So attacker tries to capture traffic on this computer. Then attacker do a update. Then attacker do this install nmap. Nmap I will I will introduce next time. Nmap is a network scanning software. So basically, when attacker try to scan any target, they will run nmap, which is most popular networking scanning software. Then this attacker closed this account. Here is about the user root, which has nothing to do with this attacker. Because we already know that the attacker has not found the root password correctly. So this is a command action we know attacker has done. So what will happen? Here is if you think that this showed too much information because it always shows this host source, you can click the list and only show the raw data. Suppose because raw data looks more concise. Of course, raw data does not show those extracted feature, but raw data can show much concise information. Like this is a Bob user account. The current password, current directory is home Bob, and these are the commands run by this Bob account. And we know attacker installed nmap, so probably attacker will use nmap to do some scanning. So we want to find evidence of activities related to the web server during the time frame of interest. So we can remove the source like and add this boost server's IP address. Suppose because the activity this authentication log only record the user's command, but if that attacker run nmap, it will generate a lot of network traffic, but that network traffic will not show up in this authentication.log, because authentication.log only remember user login, logout, and user command information. So if we want to know the traffic, because every traffic coming from the web server will go through the firewall first, whether it go to internet or go to the internal computer. So we can check the firewall log and check any firewall log related to this IP address. Firewall log is basically remember information of the IP packet header information, like which IP, which port sending traffic to which IP, to which port. So we can still use this, and source, we can remove this source. And remember, we still use this time period, basically after the attacker compromised. And here there are 3 sources. Suppose we are not interested in workstation right now. And we already checked authentication, this 17 event, is just some command. So now we are interested in checking the firewall. Basically, after attacker has compromised, what happened to the network traffic? And of course, there are so many events. Why is it running crazy? So we can fix, because we're interested in this compromised Bob account on the web server. It's traffic, it's outgoing or incoming traffic. We can fix that IP address. You type in that IP address. What's the IP address? For this 10.30.30.20. And 30, 30, 20. So basically, we show on the firewall log any packets that coming in or coming out of this web server. It will show up. So there are 3,000, more than 3,000 events, and we can see, because right now I listed as a raw, and so this is firewall log. Firewall basically keep recording which IP address, which port sending to which IP address, which port. So that's the information of the firewall. So this shows this firewall, and we can see this data is mainly about IP address. It also shows inside. So this means this packet is coming inside from internal network, from this IP address, from this port, going to the DMZ zone. DMZ zone is a zone that contains the web server, going to this web server, going to this port. So clearly the web server is not just a web server, it's also a local DNS server. So all the local computers, they will do a DNS query to the web server. The web server running multiple services. And here are the extracted fields by Splunk by default for this source. And however, here it doesn't have the information we are interested, like what's the source IP address, source port, destination IP address, destination port. They are not extracted by Splunk by default. I'm not sure why the current version still hasn't solved that issue. So we need to add this field to tell Splunk to extract them, because those are the information we are interested. Because for firewall, this IP address, port number is the most important information you want to know. So we can do field extraction. Remember, we have done that before. So you can do like event extract field. We use regular expression, and this is one event. So this is the source IP address. So we give this firewall source IP. Field name must start with a letter, and only letter. And it doesn't support this dash, so I need to use underscore. So firewall source IP, and so it asks you to verify. Next. So finish. I can extract more field because no. I shouldn't. More field. This is a source port. Firewall source port. And this one is a firewall destination IP. So you can do it together. Firewall destination port. Yeah, so you don't need to finish one and do another. You can select them one by one. And then it will show all the fields you have extracted. It seems fine. So we will just use that. Did I select this one? Okay. Yeah. So we have finished. Oh shoot, I needed to use previous search here. There's all the time. Why there is this one? Come on. Okay, so you can see that these 4 extracted fields has been added here. And we are interested in that that IP address, right? 10, 30, 30, 20 traffic coming from the web server. So these are the traffic coming from the web server. And it's a traffic related to web server. If you want to see its source, then we have this source IP. For example, if I'm only interested in the traffic sent out by the web server, so we can select this. We don't need to use this keyword anymore. We just use this field. Firewall source IP is equal to this IP address. Remember, we have extracted this 4. And if we do this, there are 3,500 events, and they are all coming from this IP address as source and sending to the other IP address. So we want to, source is only one IP address. We want to know what IP address this web server has connected to. You can see that this one connect to a lot, this one connect to this, and here, these are all internal computers. They are connected very regularly, 8666. only sending to this. And for this 3090, for this 3030, it send more than 1,000 packet. And if you're interested in like what kind of traffic does this web server send to this particular IP address, you can click that. So basically means the firewall destination IP is this. So we can see that this is from the web server to that particular IP address. And you can see this port number. You can see this port number. And it all tried in very short time, like 400 event in 1 minute, another 600 event in another minute. So this is it's in 1 second. This is 1 second, 400 event, another second is 600 event. So clearly that's a scan. So it's a flooding of a scan. And we can see what's the destination port it has scanned. You can see that it's very regular because Nmap can scan some predefined port. And it scanned is 443 is HTTPS port, is a web server port. 3389 is a remote desktop port. Like for Windows computer, remote desktop is running on the TCP 3389. 80 is, of course, HTTP port. So clearly, attacker tried to scan this port to see whether the remote computer is running those services or not. So top 10 value, if we go back to this just the source IP address and find the port number. So these are the port that has been scanned. So mainly the web server port and this remote desktop port. If we just check this firewall destination port 3389, we can see that the destination IP address is very regular, like 101, 103, 104, 105, 106. So basically, attacker scanning every IP address within the internal subnet, because attacker tried to find which IP address has computer on it, and whether that IP address the computer is running is accepting remote desktop connection or not. Because if a computer like Windows computer accept remote desktop, then attacker can try logging using Bob account. Remember, attacker already has the Bob account password. And it's also the case that many employees, they only use a single password for their company's computer, even though their company computer has many accounts. But for simplicity, they just using one password for all the accounts to log in. You can also like select like some text, then add to the search. Then it will automatically add that select text in your search field. This is useful if you only search that contain a special part of a time, then you can do that. So we focus on its Bamboo outgoing traffic, and we show that these are the port scanned. The server scanned both the web service and the remote desktop service. So that's the port scan. The other port, they only send out just the 222. So they are not the main focus point. The main focus point is that attackers scan every IP address internally for these three port. And suppose we focus on remote desktop port, and then we can see what the target has been scanned. remote desktop port is 3389. What destination IP address has been scanned? We can see that, well, the other IP address they scanned only 2 times, but this one, 101, scanned 4 times. And we know that 101 is a valid computer, Windows computer inside. So maybe this computer has some specialty that attacker scan 4 times. It connects 3 times. So we focus on that particular computer because firewall can only tell you this information, how many packets go through from which computer to from which IP address to which IP address. But if we want to know whether the attacker have logged in to that Windows workstation, firewall cannot tell you that. Firewall only show packet header IP address port number. So, but we have the Windows workstation log, so we can focus on this Windows workstation log. In Windows, remote desktop login corresponding to this logon type 10. So if we only focus on this 101 log, remember we don't need to specify the source type. Oh, we remove this and so just focus on this host, and we focus on that this computer is this IP address. I need. So you can see this source actually is this firewall log. It's only the firewall log. This workstation log does not. So let me see. That workstation log it doesn't have IP address in its its log entry, so we cannot use IP address as the keyword to search. But the workstation log has this computer name. This particular computer, this 101 computer, its name is dog WS. So we can just search for these keywords. Then the source is basically this workstation log. It will show any event that has this dog Windows, this name in it. This is a Windows log. It basically, it's just like a Linux authentication log. It record all the login, logout event. It also record the user's command in that computer. If a user logged into the Windows, then it will record what's the user command. And remote desktop logon corresponding to this logon type 10. So if you, well, this one needs some advanced knowledge. If you don't know this, then you have to check these computers log one by one to find any abnormal. But if you don't know that, you can know this log on. You can check this client IP address. If the client IP address is from this from that Linux web server, then maybe it's attackers login, because 10.30.30.20 is that, no, it's what's the Linux web server's IP address? 10.30.30.20. Well, some log, they don't have the IP address, so we cannot use that. But we can use this username Bob to find only the Bob login. So these are the 17. So right now, only 17 events left. So we can just check for all the Bob login. Maybe some of them are normal log, but some of them may be attacker's log. So this is Bob log ID, and oh, this is not reverse time order. So let me show in reverse time order. This is login attempt. And login, negotiate, and this is so this is logged in, and the new process is created. So these are the commands run by this Bob account. And we can find out its command. The command is like user Bob, and the command is in which part? Let me see. It's this command, image file name. It just means that the command is run by this Bob account. This is this command. This is this one. This is command. So basically, attacker opened a command window, and the user init and FTP. So this one is important. So attacker run FTP command. FTP is a file upload download. So attacker might have download some or upload some file from this Windows server to attacker's computer in the internet. So this is a dangerous command. So maybe attacker have sent some information out. These commands are most likely system command, but this just means attacker open a command shell. So we know that attacker have run this FTP. And what attacker have run FTP to? We can check the firewall, because FTP has a prefixed port number. It's port 21. Port 21 is TCP port 21 is a port, FTP server's port. So we can just simply search for this IP address on the firewall log, search for this IP address, and search for port 21. Then we can find out attacker sent from this. This is that logged in Windows workstation's IP address, and this is port 21. We can find out that these two events in the firewall log is related to the FTP service. So the remote computer's IP address is this one. So we know that attacker FTP something to the outside. And so now we figure out what action has happened for this compromise. The afterward response for you, if you IT security stuff, after response is that you need to rebuild these two compromised machines. And if this any user has account on these two compromised machines, they need to change their password, because attacker may FTP and upload the password file to attacker's machine. Then attacker can run offline password cracking to find password for other accounts, because a computer may have many users' account on them. Attacker right now know Bob's password, but attacker may use this password file to figure out some other user's password. So all the users using these two computers, they need to change their password. In addition, you also should limit DMZ access to internal subnet. You should not allow DMZ's computer to be able to use Nmap to scan your internal computers. Especially you open the remote desktop. service to DMZ zone, which is dangerous. It's like it's similar to your open remote desktop service to the whole internet. Any internet user can remote desktop to your computer. Block outbound FTP traffic. So you should not allow FTP if you don't have such kind of task. Consider two-factor authentication, so your password will not be compromised easily. So that's the afterword. Additional source of evidence is that you need to have some like hard drive of the two compromised machine or some other log data more detailed than just the firewall, just the packet header information and some others. Okay, so that's all for today's class. And
No, let's keep going. Can we keep going? So fun learning.
okay, it's already 3 minutes past. I think there's someone teaching using this classroom after this class.
Oh,
Yeah. I only have a few slides, but those are just some points that you pay attention, but they're not related to the case study. Okay, that's all for today's class, and see you next Monday.
Thank you.
Thank you. Bye.